Good morning, everybody. Good morning, good morning, good morning, good morning. What a beautiful day up here. So thank you all for coming. It's pretty exciting to start the new year out in such a beautiful room and a big packed room with all the bright lights. Quick announcement before we start. We are broadcasting and we are streaming to a wide audience of the OGGN network, the Oil and Gas Global Network. The network hails from 198 countries, has over 2.6 million listeners. And if we do a really good job today, maybe we'll hit 199 countries. Also want to give a really special thank you to our sponsor today, which is OGGN. Thank you very much for sponsoring today's program. Now let us begin by our invocation by Jay Sims from the Oilfield Christian Fellowship.
I can't say something before I had to say something first. Did y'all anybody read the article from ESPN Sports on the fellow who collapsed in the football field? Did y'all read that? I'm sure tickled pink. They went to their knees and they prayed for God for his guidance. And I appreciate that. That's what I want to do for you today. Heavenly Father, we thank you for the time we have together. We thank you for this great group, these two organizations who are Bible and help us out. We want to also bless the people that are here, their families, their friends, their loved ones, Lord. Bless the food and nourish our bodies, Heavenly Father, and we love you and praise your name. In Christ does these things. Amen.
Thank you, Jay. And now from AADE, will Rusty Ritz please come up?
All right, it is great to be here, and for all these years that we've had this connection with AD and API, and you know, the camaraderie. We're all fighting the same fight and living the same lives. So we are so glad to be part of it. And as long as I'm connected to ADE, we're committed to it. So thank you guys for having us today. We're always proud to have a joint meeting with you guys. Just a few announcements for us, and I'll get out of your way. Time to renew your 2023 membership. If you haven't, it ended last year at the end of the year, so go online and do that. A few events coming up. January 19th, we have our Innovative and Emerging Technology Group meeting. This is free to attend. It's at Transocean's building. Thank you for hosting us this month. The topic is exploring alternative applications for oilfield expertise. Again, they're free to attend. We have a panel, several speakers. We're very glad to provide that service. Hope you can make it out to attend. On January 21st, we have our casino night, our annual event. It's sold out. Unfortunately, if you don't have tickets, you can't get them, but you may know somebody who has some. There seem to be a lot of times people looking for somebody to invite their last minute. So if you'd like to attend, reach out. You can probably find a ticket here or there. February 2nd, we have our luncheon meeting here. February 16th, we have a fluids management group meeting. Again, it's just like the other technical group meeting. It's free to attend, and that's at the Norris Center out on I-10 and the Beltway. Hope you can make that. Do we have a topic for that one yet? Okay, be on the lookout. That'll be announced. March 27th is our annual golf tournament at Black Horse. Information for that will be coming out next week. Hope you can participate. It's always a great event. And for the second year, this is March 30th at Texas A&M. There's an AD student section event. It's the Lloyd Pete Hughes networking event. It's also a fundraiser for some military organizations that support in that area and elsewhere. Last year, if you noticed, we started having happy hours about once every couple of months, and good networking events. We'll be kicking those off in February. So be on the lookout for that. Again, thank you. Look forward to the meeting today.
Thank you, Rusty. Now, back in September, we had our first meeting. I call it the season. It's the first meeting of this format, where we have a panel of industry experts, and we talk about a highly relevant theme, and it comes with this actionable information. It was really a great success. We've had thousands of people view that program across all the platforms. I have no doubt that today will be the same. We have a beautiful array of cameras and bright lights and the whole deal. A couple quick announcements for API coming up. February 14th, we're having a joint meeting with IADC. Yes, that is Valentine's Day. So we're going to do our best to make it heartwarming. February 17th. This is the big one. February 17th, we're doing something we haven't done for quite literally generations. It was the 1980s since we last had a gala. So I wanted to say real quick about this gala and about who are we? What do we do? What is the purpose? So what is API? API, well, it's a professional organization. We share information. We share intelligence. We meet socially. We form new relationships. But most of all, we help the next generation. And how we do that is we raise a significant amount of money, quite literally millions of dollars, for our scholarship endowment at major universities. That's the purpose of our upcoming gala. It's to raise money. It's to have fun. I mean, frankly, we have to have fun, right? That's kind of the point. So with that said, I want to bring up Miss Amanda Labrie. She's from the Social Tank. And Amanda is our gala organizer.
Hi everyone, my name is Amanda Labrie and I will be hosting the API Gala on February 17th. I don't know if we have a slide or not. Just to piggyback off what Justin said, the theme is moving America forward, right? We're all in the oil industry together. And being that we're here in Houston, everything's centered around oil. No matter if you're in banking, medical, education, oil is the center of not only Houston, but of America and our world. This year, we will be honoring Gardner Parker. I don't know how many of you know him. He is a lifelong Houstonian, served in the military, has owned multiple oil and gas companies. Currently, I couldn't list them all. Our wonderful interns have put together a list of all his credentials. Yet, he is somebody who reaches back in the community, pulls people together, raises money, and prepares the next generation to be better than ours. I hope you can attend, get a table. They are going quick. It will be at the Houstonian, and we only have 36 tables. And that only means we have 34 up for grabs. So at a 10 top each table, 340 people is all that's allowed. So get with me. I have my business cards. You can find me on LinkedIn. We're obviously live streaming this. Let me know as soon as possible. I'd like to give everybody API, of course, first round draft pick to get a table. And also, it'll be a roast. So, I see some laughing. Yes, that may make some of us nervous, Justin, but we'll probably have Bill White, Amanda Brock, Steve Kennedy, I have some others up there with Gardner Parker roasting him. He is an incredible person. You will have a wonderful time. Thank you, guys.
Well, I guess it's been decided we're having a roast. Okay, who is excited to talk about robotics and robots today? Okay, maybe a few claps? I mean, come on, that was weird. All right, let me introduce our key man who's me, the moderator, that's the right word, the moderator. He is Mark LaCour. He's a longtime board member of our Houston API chapter. He's both the editor-in-chief of the Oil and Gas Global Network, who is broadcasting us today, the OGGN. And he's also a director at Modal Point. I like to say this a lot. He's had over 25 years in our industry, has had quite literally thousands of meetings with probably every oil and gas company, and he's even met with my fifth cousin in Kabul. Welcome, Mark LaCour.
Hey, everybody. It's good to see all these faces in the room, isn't it? So a couple of things. Justin mentioned earlier we're in 198 different countries. We had one country left in South Africa that we had no listeners in. I was about to pay somebody to listen to us so I could say we own the world, and we picked up 4 listeners in November. So we now have listeners in every single country on the planet, which is pretty cool. No, it's not nothing to do with us. It's just cool. We're live streaming this right now. So if you open up Twitter, Facebook, LinkedIn, Discord, and search for OGGN, you'll see yourself on the video stream. Last time I checked, we had a couple thousand people from around the world joining us. That's going to grow as we start the program. I'd like to call our panelists up so we can get started. Come on, guys. Grab a chair. It's hot up here. All right, so in no particular order, I have John Martin. He's president of Offshore Robotics at ARC Specialties. If you don't know ARC Specialties, I think they're the only American robotic manufacturer here. Dan's here somewhere. It's a great company. They're doing some great stuff. Craig McCormick, Senior Manager, Innovation and New Technologies at Transocean. Got to put my glasses on. Matt, Senior District Manager at FANUC American Corporation, and Carlos Underwood, Rig Manager, Operations at Transocean. Thank you, gentlemen, for giving us your time today. This should be fun.
Thank you.
All right, so let's just start the conversation. Let's discuss why the adaptation of new processes and technologies takes so darn long in our industry.
I guess that's a really interesting question, Mike. So I
Can
think
you
if
pull
you
up to
look,
the mic a little bit closer?
Yeah, sorry.
There you go.
If you look back, even back to say the 80s, you know, the technology that was on everyone's lips back then was a top drive, right? And it's on every rig we have today, but it took probably 15 or 20 years for it to become adopted. So there's a lot of barriers there, and I think the key barriers are most of the technologies take a rig out of service to have them implemented. They're costly, and you know the industry itself is resistive of change. We know what we know, and we like to keep knowing what we know. So I think that whole process takes quite a lot longer than other industries.
Yeah, and that resistance to change is also in our core safety culture, right?
Yeah.
If you have a process or a tool in place and nothing leaks and nothing blows up, you don't want to change that process.
Yeah, one of the things that we see a lot of at Transocean is there's a lot of companies that want to go second to get a new technology on their rig. No one wants to be first.
Yeah. Any of our other panelists want to chime in on that?
I will. I'm John with ARC Specialties and Offshore Robotics. So we're the ones in charge of putting these robots out in the field and getting them to work. That's the most important thing, is when you take a new technology out there, it's got to work. Sometimes when you're doing it in the shop floor in a manufacturing environment, it's really a controlled area. It's things that happen repeatedly every time, and you can control that process. Offshore and many other onshore type of applications, the process is pretty uncontrolled. It's pretty varying. So you have to create your robot and your automated system to adapt to those circumstances. So I think that's the entry, or the hard part for entry into the market, is the costs are so high per hour that you've got to be right the first time. And that's where some people are a bit hesitant, I think.
Yeah, it makes a whole bunch of sense. Any other comments around the adaptation? No?
Yeah, I'll jump in there if you like. So I think to John's point, we rigorously tested this system in every condition we could possibly conceive in the manufacturing environment. But the lessons we learned once we got the system into the field were, quite unbelievable. We thought we'd tackled, every area, and we left a few on the table. So we apply an after-action review process within Transocean. I'm sure that's common with most drilling contractors. But we use that after-action review process to take feedback from the guys in the field, apply changes to the technology to make it either easier to use for the guys, or perform better than it did previously. So we've been in an iterative process. with this system. For those of you that know riser running, it's not something that we do offshore every day of the week. It's a few select times per year at the beginning and end of a well. So there's limited opportunities to learn these lessons. So I think that's been probably key for Carlos and myself, to get that feedback from the rig in as much detail as we possibly can, so that we can feed it back to John and his team to make the changes to improve system.
And that's also important to get the involvement of the people that are using the equipment. And that's where Carlos comes in as a rig manager to buy in on the technology. And without some support from that type of person or a team of people, you're not going to get a successful implementation.
Yeah, that adoption by the frontline people is super important. So perfect segue, by the way. So what's going on today in oil and gas industry robotics, and specifically at Transocean?
Sorry, I missed the question.
So what's going on in robotics today in the oil and gas industry? Like, what's real rubber hit the road? And then more specifically, what's Transocean doing?
So I think if I say what's Transocean doing, we're doing a lot, but we're being very targeted in what we're doing. So we've got a very deep roadmap of technologies that we could work on, but we're very tactically selecting the technologies that will have the biggest impact across 4 pillars. So those pillars that we tackle are personal safety, operations integrity, the environment, and specifically emissions, and then also improving our performance. And so we look for technologies that will at least hit more than one of those big buckets and have a significant impact in those big buckets. So in the case of robotic riser, it's our largest resource-loaded activity that we have on the rig. It takes the most people out of any other activity in well construction. And it puts the most people out of any activity closest or in the red zone out of any other activity that we conduct. So, upwards of 5 guys right at the rotary table in and around some of the heaviest things that we handle offshore. So the target here for us was to remove our people from the red zone, so remove folks from harm's way, and improve performance. So by applying the robotics technology that we were able to work through with John and the ARC team, we've been able to see where we can improve our riser running performance from around about 4 to 4.5 joints per hour in this class of rigs. We've been knocking on the door of about 6 joints an hour.
Wow. Yeah, we're gonna have some video a little bit. If you don't know what a riser is, a riser system is, we have some video to showcase it. It's amazing what they're doing. And then, ARC, when you're working with Transocean, you're having to figure out the actual physical requirements to get these type of jobs done. Can we get into that a little bit? Like, how do you figure out what needs to be done, and where does the robotics fit, and where you need to apply that technology?
Right. Yeah. A little bit of a history on the project. It started probably a year and a half ago, and so we developed a design, and we just do everything on CAD models and do as pretty much simulated as we can within the computer space. And then we go into prototyping to prototype and test these tools. So we learn a lot there on how the system works and how the different features of the part are going to behave under the sensor technologies that we use. And then you go and implement it into the field, and that's where you really learn a lot about it. A little bit about the robot side of it. If Matt could talk about some of the technologies as far as the FANUC brings it to it.
Sure. Yeah, in regards to new technology, FANUC's first robot came out in 1982, so that's not really too new. It's just implementing it in this kind of environment is a new process right now. But technology, every year it's better and better. Robots are getting smarter and smarter. But it's our team in Michigan and all over the world that can assist our companies like ARC Specialties and Transocean with support and getting these products out there and having a successful project at the same time.
Right. Any other comments around this?
Yeah, if I can, maybe to pull us back a little bit and pull some color into that. So for Transocean, we come up with a concept in, we didn't come up with a concept. We had a problem we needed to solve in 2019, 2020, and in early 2020 we engaged with ARC Specialties and said, hey, this is the problem we have. We've got guys that are hurting their fingers, hurting their backs, The industry's seen more significant injuries in the past around this really heavy activity. We want to automate it. Is this an opportunity for robotics? And so we went through this concept development phase with ARC, where we arrived at, yes, this is actually feasible. There's work to be done for sure, but it's feasible. So we shelved it and said, hey, in 21, we're gonna take on this project. And then in August of 2020, there was a fatality on one of our competitors' drill ships in the Gulf of Mexico. A young man lost his life while they were running riser. They got a riser wrench stuck on a bolt, and in the process of removing it, the wrench struck the guy, knocked him off of the spider, and he fell over and was pronounced dead. So we immediately took the concept to our innovation committee, which is a group of folks internal that made up of our executive group that determined when and what we will work on. And we proposed this, and within I think a week or two, we were actively working through the concept with the team at ARC. From there, we very quickly assembled an internal work group made up of folks from operations, engineering, and our tech development group to make sure we had all of the right stakeholders in the company involved to bring the right set of experiences to bear. So we feel like we know what we're doing in terms of drilling, but we certainly did not know what we were doing in terms of robotics. So we had a lot to learn, and I think John will probably agree, ARC had a lot to learn about offshore drilling.
Yes,
so
it was the first time
that was the challenge. It wasn't, there was a lot of technical challenges, but the first challenge was understanding what each other does.
Yeah, so John, you got to comment on the other side of that. So Transocean reaches out and goes, hey.
Right. Yeah, he says we can't change anything. And so a lot of times when you're automating something, you ask a customer, I'd like to change something on their part. But unfortunately, they got all these riser strings already purchased, all the bolts, everything's already there. So very difficult and expensive to change that. So you have to work within the constraints, of what they got. And it makes automation a little bit more difficult when you've got to create your product or your system to work with those types of, rules. And also it was the first time we went offshore, so things like marine growth on bolts, that's not very common in industrial applications. And then vessel motion as well. So this whole system, of course, is in a ship in the middle of a body of water, and it's moving around, and the robot's got to perform just as good that day as it does on a sunny day, as it does on a rainstorm right before a hurricane. So a lot of steep learning curves were involved in doing that. Yes.
Carlos, I think that was probably one of the topics we talked about the most. Was the ARC team would ask us, okay, does this riser system move? And we puzzled over, well, I don't think so, but how much is move? And so we really found it difficult to articulate how much a riser system moves and whether it's in the same place every time.
It turns out it's quite a lot.
Yeah, quite a lot, and it's never in the same place twice. And I think that was the real challenge of this project is, you're used to seeing robots in an automotive or a manufacturing environment where everything is always in the same place. In this case, it's never in the same place twice, and I think the techniques and the technologies that ARC's applied here to overcoming those challenges is what's made the project successful, and it's really the springboard for more stuff that we want to do in the robotics field.
Yeah, I think this is a good time to go ahead and roll the video. Can we do that, guys? And Carlos, if you want to kind of talk through
if I could see
what's
it.
going on. See?
Can I come over so I can see?
Hell, yeah.
Give him your mic.
Yeah.
There we go. Hey, so now, one of the couple of things to add to that, is manual handling as well. We talked about reducing personnel from the red zone and making sure they're not in that area. But as you can imagine, that jointed riser right there, for those that don't know, is 75 foot long. That flotation joint weighs upward of 60,000 pounds, right? So a lot of moving pieces that you take a chance of falling out of the derrick on top of somebody's head, right? So there's that part of it, but also what the robots are doing here is normally in that small work area, you have 4 people in that area making those bolts up. So right here, as you can see, the robots are actually going and getting their own bolts. They're putting them in, they screwed them in with the multi-tool.
And then now they went back and picked up their torque wrenches, and now they're going back and applying that torque. And that's completely eliminating people in that area, which is what the big, huge part of it was. Not only reducing the people in that area, but also reducing and eliminating the manual handling part of it, right?
So this is what amazed me about this. Those nuts are 55 pounds. This robot's handling unbelievable amounts of weight, pressure, while everything is moving with the precision that people just couldn't continuously do. It's amazing to get this done. And what's really fascinating to me is now y'all accept this as like standard. This is what the future's bringing, right? This is how the risers are going to be put together from now on moving forward.
I wanted to talk a little bit about the 55 pounds you talked about. So that bolt, that's, okay, a bag of cement's 40 pounds, somewhere around there. So imagine hauling that, not just once, but you're doing it for 12 hours a day. It's very tiresome on the people that are doing the task. And it's one of the few applications I've worked with where the operators, the floor hands, they are seeing these robots doing the job that they used to do, and instead of being upset, they come and thank me. They say, thank you for building this, because they don't want all these bolts every day for 12, or all day
it's
for 12
amazing
hours.
some of the data that you look at. So part of the analysis we did when looking at this project was an average rig would manually handle 70,000 pounds of bolts in an average year. That's a lot.
And if you look at the amount of hand injuries we had handling bolts, it's a huge amount as well.
Yeah.
Yeah, it is you got me? Okay. So, so looking at this is a great step. I mean, it's awesome that you've taken people out of the red zone. You know this has increased safety. This also has to increase the integrity of the riser, right? Because you're having technology make the assembly, and the robot doesn't assemble it differently because he got a fight with his wife or it stayed up too late last night or whatever.
Yeah, we have about 30 some odd pieces of what we call fault logic in the system. And we use those pieces of logic to do a couple of things. A, help the robot overcome misalignment of a riser joint. So, find the riser if it couldn't find it the first time. But we also use it to determine whether there's a bad thread on either the bolt or the threaded insert in the riser, and that will alert the driller that, hey, there's an issue that needs to be addressed. So in terms of longevity, yeah, I think that plays into it. But also we know that riser flange is torqued to the exact specification of the OEM every single time it's made up.
Yeah, and you got more equal torquing around it,
yes,
too, because not one's torquing up ahead of the other like you would with floor hands up there doing that job. And then so that's a huge part of it. Then we also are able to go back and look at what torque we put on them, which we never had before.
Yeah, exactly.
To analyze it.
So this, the two systems we have in the field at the moment are both on Cameron riser strings, and we're in the middle of, we're just starting manufacture. Actually, we just finished engineering of and into manufacturing for an NOV riser string on one of our new 20K drill ships.
So John, I have to ask you, the ability for those robots to assemble with that level of precision, is that something that ARC already had that you transferred to this project, or is it something that y'all helped develop for this project?
We used pieces of our technology we used in other systems to do the process. So a lot of our stuff that we do right now is for welding industry, and a lot of the welding is adaptive. You'll hear people out there in the world, they call AI artificial intelligence, and they say, well, is your machine learning? Well, no machine is actually learning. Out there, what they're doing is they're adapting. So let's let the people think about what to do and put those programs and those algorithms in to accommodate for the different scenarios that it's going to be introduced to. But we're taking a lot of force sensing, a lot of laser, a lot of camera feedback information into projects that we've done in the past and putting them all into one system. So this system here has about every sensing technology we've done in the past, almost every one of them. So there's quite a few in there to make it adaptive.
Yeah, perfect segue to my next question, which is, you mentioned earlier about automotive. When we look at other industries, where and what are we looking at from a technology adaptation point of view? Where can the oil and gas industry learn from other industries?
Oh, that's a good question, because I guess the sole purpose of this project was not to go out and build a custom robot to work in this situation. It's to go and buy an industrial robot that's millions of them have been built and millions of them have been improved over time. And the automotive industry has been using them for years, and because they don't fail. So take that technology and modify it, incorporate it, put in the IP rating in order to work in that type of area. Yeah, it's based off of technology that has been developed in automotive and any other manufacturing.
Yeah, and from a Transocean perspective, I wouldn't say we only look outside of the oil and gas industry, but certainly over the last few years, we've intentionally looked outside of the oil and gas industry to see what other industries are doing that we can leverage. What we've found is it isn't always a direct match, but certainly in the case of the robots here, that was not. In hindsight, wasn't probably the easiest project to tackle as our first robotics project, but it's, I think the collaboration between, in this case, drilling contractor with a key supplier and our customers' influence is what's got us a successful system. I think the typical approach of a manufacturer anticipating what the industry might need, developing a technology, and then selling it on without the end user input is a little flawed. And I think that's an area that we strive to do better in by creating the right partnerships with key suppliers.
So this leads me to my next question. Somebody had to sell this in Transocean, right? How do you build a business case to put this amount of capital expenditure into something that's never been tried before? Like, what are the metrics that you're looking at?
It varies technology to technology. In the case of robotic riser, it really boils down to speed of running the riser and over a period of time. So if you look at most operators today, have a target return on investment in around about the 18-month time frame. So we've been pretty targeted on technologies that will give that return in that time frame. In order to have a department like ours, we need to be compensated for that. So we look for various ways to achieve that. But usually, when there's a compelling business case, that's a fairly easy discussion.
And that's one of the things you shoot for as well is efficiency, right? And in efficiency with robots, you want to build repeatability. When you talk about human interaction and making up bolts, you may have sometimes where they can make up a connection in very little time, 3.5 minutes, but the next two may take 18 minutes, right? Yeah. So you want repeatability. Yeah, it may take 4.5 minutes, but it's because you want to build that steady 4.5 minutes.
That's right. Yeah, the robot's definitely not faster than the fastest crew on a joint by joint basis, but you watch that crew just right after dinner time, and they're not quite as fast as they were right before dinner time. So the robots will win on consistency every time.
And they don't need lunch.
Yeah. Matt, when you work with your customers, what's some of the things that you do to help them build the internal business case to make an investment like this?
Well, obviously, it's the ROI is a key. How many shifts are you running? Is it multiple shifts? Is it 24/7? Obviously, the more shifts, the better. The easier it is to get that return on investment. But again, it's not going to stop working. It's just going to work and work and work no matter what day it is. So it's pretty easy, especially like I said, if you have multiple shifts to get that return on investment quickly.
Yeah, John, any comment on that business case?
It'd be better for my sales guys, but from the technical side of it, I look more at is it physically possible? Because you could put out there and say I can do this many in a month, but is it technically able to be done? So that's where I kind of bring sales guys back a little bit and say let's look at the nuts and bolts of this and say can we actually do it? So that's for me proving to the customer that you've looked through that and did that background. They can make the dollars and cents maybe work, but they need to have a good feeling you can actually get it done.
Yeah, John made a point earlier on about getting it right on day one. Really big deal for an offshore rig, right? It doesn't really matter the day rate. It's and no matter which way you calculate it, it's a lot of money per hour. And so achieving the business case on day one is really quite difficult to do. I think any technology that we're employ on a rig that has been tested in the shop as best as we can will have a break-in period. But it's how you manage that break-in period and the opportunities that you seek within the operation to establish the performance of the system offline is what gets you the business case as soon as possible.
Yeah, so we talked about the business case, the finance. We talked about the HS&E impact of this. Talked about the ability to consistently put the risers together. One of the things I've heard a lot is I'm worried that robots are going to take my job. Can we talk a little bit about that? The elephant in the room?
Yeah, I think John made the point there earlier on, but it's one that comes up, right? Particularly on social media. I could almost guarantee you a third of the responses on the live stream here will have that connotation to it. But the reality of this particular task offshore is that the guys that are usually performing the task when it's done manually really do not like that job. And we have made zero effort to replace people with robots.
So I guess to add to that, one of the things that I see as a rig manager as a benefit to it is it actually allows me to reallocate my resources, right? So I could take the number of people I had on the rig floor working, I can move them to other areas working, then I can take the people I had helping with the job, say down in the moon pool, and I can now put them doing in-between well maintenance, which has got to be done, which at the end of the day will reduce the critical halftime of your between well maintenance for your customer, right? So it's all about reallocating your resources. You're not, just because you're removing them from the rig floor, you're not removing them from the business. We still got to support the robots, we got to feed the robots. But the other part of that is too, now I can take on more work scopes while I'm pulling riser because I've freed up that many more people. Because once that BOP hits the deck or gets latched up, that's when the extra work starts, right? And for a pool, you may have 3 days of out of service period, basically, if you will, planned maintenance that you've got to do to maintain the rig. So if you can reallocate those resources to starting that maintenance earlier, then you're reducing that NPT time, if you will, for your customer.
Yeah. John, any comments on robots taking people's jobs? You've been doing this for a long time.
Yeah, a little bit. I see it more industrial applications. This one here in particular, not at all. And I've asked several drillers after they've ran the system and have worked with the system if they like it. And the drillers, I just ask them, do you prefer the robots or do you prefer your guys out there doing it? And they almost 100% say robots. And the reason that they tell me that is because they are the safety coordinator on the drill floor. When those hands are out there underneath this riser or in the red zone area, it's, they're responsible for it. So if you take them out of there, it lowers their stress level to a point where now they can concentrate on lifting the riser and all other stuff that needs their concentration. So there's benefits in I guess taking those tasks away from the people that are in the management roles as well.
Yeah, Matt, you want to chime in there?
Yeah, I mean, there's just to that. I mean, a lot of people coming out of college nowadays, they don't want to get dirty anymore. They just want to work from home, and it's way back in the day, yeah, there was always the stigma of, hey, we're taking away jobs, but yeah, people are going to be moved to do other jobs that aren't so tedious or so hard on their muscles or anything, so that they can retain and move on and do other things. But yeah, it's just right now, it's finding people to work is probably one of the hardest things to do.
Yeah. You guys have an easy time finding people on rigs?
Just a little bit challenging.
I think the conclusion we arrive at Transocean at least is there's no one technology that we'll put in the field that will reduce the crew complement. It needs to be an array of technologies before we ever arrive at that decision point. And frankly, I think that decision point's quite a few years away yet.
Yeah, and I would think somebody has to build those robots. So there's a couple of jobs being created, right? That's what ARC does. I'm getting ready to wind this thing down, so everybody can start thinking about questions. We're going to go to Q&A after my last question. Stay away with everybody that's online, Twitter, Facebook, Discord, YouTube, Twitch. If you have questions, hit them in the comments and we'll get to some of those. So winding this thing down, when you look at the advancements that we made as an industry, which really is cool. Last data set I saw, which was 2019, in the U.S., it's actually safer to work in the oil and gas industry than to be a realtor. I mean, we should pat ourselves on the back for that, right? I don't know what's going on in real estate, but we've become so safe. When y'all looking in the future and you're looking at technology, what do y'all think that the future's going to bring for oil and gas, for technology in oil and gas?
I'll go back to the roadmap we talked about. For us, it's automation of manual tasks, so removing the person from the red zone primarily, and I think it's specifically automating manual tasks where we can improve performance of the drilling operation overall. So we've got to concentrate on affecting the person in the red zone and the critical path of well construction, so that we're providing value back into the industry. And then the next tier is, okay, the non-critical path activities that are currently conducted manually. So I think that's, like I say, we've got a pretty long roadmap there of things we want to work on, but we simply have to be targeted in how we execute to that roadmap.
Yeah, and Carlos, your boots on the ground. What do you see coming down the road?
Sir?
I said your boots on the ground, right? You're out there running the rig. What do you see coming for the future of our industry as far as technology?
I think back right now we're finishing up SPS for my rig, and I'm just sitting there thinking about the reduction of putting people in those hazardous situations, right? We just done SPS, and in the SPS you got to make all these tank entries and do all these tanks inspections and all of the ship. Most of those we done with mini ROVs, we reduced putting somebody in a confined space. Now we're looking at it as robots, putting robots on a spider and gimbal. We're looking at other avenues. Where can we use these same robots to help automate or take away that physical labor part to help with the personal injury rate and reducing that. So I think the biggest part of it is open-mindedness. I came in from the field 2018 to shoreside, and it's been a transition for me, because I was one of those roughnecks at one time that said, robots never going to take my job,
Right.
But now, like John and everyone's alluded to, the open-mindedness of the personnel offshore, I think it's limitless on what the potential is in years to come, with automation and with robots.
Yeah. John, any comment?
I do commend the industry for being very safe, because going offshore, you got to go through a whole bunch of safety training classes, and even once being off there, the industry standard is to not have any hands on anything. Impact resistant gloves, you're using push-pull sticks, you're not allowed to touch lift loads, which a lot of crushed hands and stuff work, but that also limits the people's ability to be efficient, right? You're putting in safety barriers, but you're also most of the time slowing the process down. So it opens it up for automating, because now we have there's a cushion now you've built in. It might not have been fast as they did it 50 years ago because they're a little bit reckless, but now with the safety protocols in place, a robot can be more efficient and much safer, because you completely eliminate the person in that hazard zone. So that's where I see the future going.
I got to ask you, did you have to do Hewitt training?
I did. I did Boise at those is all day.
That's one hell of an experience, isn't it?
It is upside down in a helicopter.
Yeah. Matt, any comment on what you see the future bringing?
It's just the future. It's like I said, more manufacturing jobs. People are not going to be wanting to work in those dirty environments, or especially the unsafe ones. That's perfect for a robot. It's going to work 24/7, and then it's not going to complain or get carpal tunnel syndrome or anything like that.
Perfect. All right, Diego, you finished eating? No, your mouth's full? Because what I'd like to ask you to do is walk around, if you don't mind, when people have questions with this microphone, so that I can open up social media and grab those questions there. So if you have questions for our panel up here, raise your hand. We'll walk a microphone over to you.
Good afternoon, gents. Annie McKenzie, NOV. This is more a question to FANUC and ARC Specialties. How have you saw the robotics standards like RIA 1506 tie into oil and gas standards and regulations? Have they kind of made it easily? Because a drill floor is essentially a collaborative work environment. So how have you seen that kind of play out as you went through this exercise?
Yes, the standards we built the system to are IP67 rated, so that's a foundry rated package from FANUC. And then the peripheral tools and everything like that, we spec components and designed the system such that it was pretty much submersible type of rating.
Sorry, what I was meaning was the safety environment, the risk assessment of the drill floor, for example, how the robots may or may not need to collaborate with human activity. Sorry.
Correct, yes. That was mostly handled by the Transocean here with their procedural, I guess, procedures and that kind of stuff with the risk assessment of the operation of the robots. So it's within the customer's procedures.
Okay, thank you.
Other questions? Raise your hand.
Cosmin Bozanovici, Marshall Islands Registry. How do you move the robots in and out of position?
That's a good question. So when we rig up and rig down from running riser, it's critical path time, right? So we started off by lifting the spider and gimbal into place with the framework for the robots as one unit, and then the robots separately. And we migrated to lifting it in as one complete assembly. So the robots actually have a protective cage that goes over the top of them that enables them to be lifted in and out separately if we choose to. We have an indexing plate so that we don't have to re-index the robots once they're landed back onto the spider and gimbal. And we handle the tools in a dedicated tool basket, and we actually put the tool basket where the bolt bin is, and the robots will go and get their own tools. So we don't actually handle the tools manually either. So I'd say we've migrated from sort of a crawl, walk, run approach. We're not quite running, but we're within benchmark times for rig up and rig down for riser running.
Yeah, the most difficult part of the rig up process is the cabling and the hosing that is required, because the robots are servo actuated motors. There's 6 axes that are all precision with electric motors. So it does take a fair amount of cabling. So it's umbilicals that we design that plug into the back of the robot to our control enclosure.
Thank you very much.
Chris Parker with Abco Subsea. We've been approached about taking the man out the moon pool, and I guess it's more a question for Craig. What are your thoughts on that as far as clamping, umbilical routing, that sort of stuff?
Yeah, that's a good question. It's also one that's on our roadmap as well, without giving too much away there. But I think the way to approach that is, I mean, any area where you've got people in an area of elevated risk, and certainly, over water in the moon pool is an area of elevated risk, is an area that's worth considering. In terms of performance improvement, that's an off critical path activity, so it's very hard to make a business case, a performance-driven business case. Certainly there's a safety-driven case there.
Hi, Denise Trabig with Emphasis Consulting. First, I'd like to thank you for the contribution you're making to the industry. I think everyone can agree in this room that any fatalities hurts all of us. With that in mind, are you guys at liberty to share what it cost to produce the robot in hopes to share it with other companies like yourself?
I'll leave John to answer that question.
Well, you could as a business case, what I guess is it fair amount to say what the business case is based upon an 18-month ROI?
No, I think, look, the business case varies drilling contractor to drilling contractor. So I think the price tag's in the $2 to $2.5 million range.
And it depends. There's different things. It's about $2 to $2.5 million depending on your application, because riser's not all the same. You got NOV riser, you got camera riser, you got bolts that are retained, you got them not retained. Some got bolt bins, some don't. So it just depends on what type of, I guess, features you got in that application.
Thank you, Rusty Ritz. Appreciate you gentlemen being here. We love this format too, so hopefully we can do it more. And you guys touched on this quite a lot. Just a couple of follow-ons. It kind of, in the chicken and the egg, Transocean said, hey, we're thinking about this. We're looking at what robotic applications we could apply. What's that interaction now as you talk about the evolution? And Carlos, you said you guys are thinking along those lines about what's next, what can we do? And being on the drilling side as well, I know how we think, but when you're on the robotics side, are you seeing things that your group in the interaction is saying, hey, have you thought about this? Can you take this and apply? Just curious about the evolution going forward.
I think, I got come into this project a little after it got off the ground because my rig got selected for the robot package, right? But when I went over to Offshore Robotics and we had discussions and I was looking at what they had, it's amazing the give and take. I mean, we'll come up with an idea and say, hey, no, this is probably not right, and these guys adapt. That's what they're in the business of adapting. And I've thrown all kind of curveballs at them, being a roughneck. I said, man, there's no way I'm gonna make it fail, right? And to be honest with you, they've got everything that you need to make it work, and others into that. And then when they're out on the rig as well, John and his first trip offshore, that was one of the things. Hey, go around, look at some of their other operations. What can you bring to the table, So that was a big ask when they went out. So.
Yeah, we meet weekly together. We've been meeting weekly together since 2020, mid-2020, I guess. And that meeting includes guys from our rigs offshore, certainly drilling superintendent, maintenance superintendent, the work group that we've got within Transocean. It involves operations, guys like Carlos, our engineering team in particular, and the team from Offshore Robotics and ARC. And what we've found is their approach to solving a problem is just a little different than ours. And there's some really simple stuff on that video if you look closely. Using the shape of a hex on a hull cover is not something we would have necessarily thought of, right? We thought this was going to be a 5-tool job, and they distilled it down to 2 tools. So I think their approach to solving a problem is different. I think that's the benefit in looking just a little outside of our direct, industry. I think, ARC would say, they're in and around the oil and gas industry. You just might not have heard of them before. But certainly their exposure to other industries, automotive in particular, and cases like that is really something we can build on and grow with.
It happens a lot for us. We go out to a customer to look at an application that they might want to try to automate, and we'll just be walking by a pallet of parts and say, what are those? And they're like, oh yeah, we do those too. And we're like, you should start it there. Automate that first before you try this usually complex problem here. So look for the simple tasks. Have us come out, walk your facilities, and that's what we try to hone in on. And we do that quite a bit. Our sales guys and our owner, he even goes out. He loves going out there and showing people what they should do and not. And if you want to, he's got a whole web YouTube series on what to automate and how to do it. So.
Yeah, so we do that in the format of after-action reviews. So after we've run the system on a riser run or a pull, we'll have an after-action review that the rig team leads and we listen to. So we're taking that feedback directly from the field. And at that point, we're looking at corrective maintenance. Has anything occurred that needs to be addressed? Is there any improvement opportunities, that might exist? Carlos and I take that back. We'll understand, okay, what what of that work scope needs to be handled directly by Transocean. I'll work with John and the team on, okay, what do we need to do to the system to overcome and improve. So that's an iterative process. I think it's one we'll be in for a while, but I think we're getting to the point where we have the performance and reliability that we expected to see. In terms of maintenance, I think we've got to gain some more field experience before we can truly say, hey, this is the level of maintenance this system's requiring. The robot itself, I'm not at all concerned about. I mean, those things are good for millions and millions of cycles, and we're not using a tenth of that life cycle. Some of the bespoke tooling that's been developed, it all uses components that are that have high life cycle to them. I think as a system, we just need a lot more field experience to really learn what the ultimate maintenance is. Our design maintenance is infrequent end of well checks, and the intent of the system is that it'll be in the field for 10 years.
I guess to add to that, Craig, too, though, we tried to be very proactive before we sent the first set to the rig. We brought in people from the rig to do hands-on training, right? Operated, hey, this is a robot, this is what it does. And we actually brought in a big group of people, whether it was ETs or drill crew, right? So after the first deployment, we realized, hey, we may need to tweak that a little bit. So we actually set up another training course for the ET side of things, right? Because that's where, if you get into some troubleshooting or setting up or whatever, the remote support from these guys and having somebody that can do that. So there's a big push up front to make sure that your people are familiar with the system you're sending out.
That's a really good point to hit on. So I think in total we've done 7 riser runs and 3 or 4 riser pulls. And I think it was 2 runs ago we got to the point where we're actually doing live support remotely with Offshore Robotics on Teams, rather than having to bring them out to the rig. So that is a testament to to Carlos's statement around training the guys and getting them to a level of comfort, and then Offshore Robotics providing that remote support.
Right. No, I'll back that up. It's training, training. You got to get your technical guys involved in the process, and they need to understand it. Yeah.
All right. Speaking of technology, we had a wireless microphone fail in the middle of all this. But we have a backup because we work in oil and gas. So I got a student from the UK says, oh my God, I had no idea oil and gas industry was this cool. What do I need to get my degree in to come work with robotics with Transocean?
I think he just needs to reach out to me on LinkedIn, and I will love to make his acquaintance.
Okay. All right, so we have another question. How is robotics offshore impacting ESG metrics?
That's an interesting question. So I guess it depends on your individual company's metrics and how they measure their emissions reduction goals. But by and large, if we drill the well more efficiently, there is less emissions created to generate or to produce that amount of oil. So I think we're improving performance, therefore, as a byproduct, reducing emissions.
All right, we got a question from Australia, which is, what, 3 in the morning over there? I don't know who's watching this 3 in the morning, but thank you, I guess.
It's Craig's mom.
Will we see a fully automated drill ship?
Our long game is press play, drill a well.
We got another question about employment at Transocean. I guess English isn't their native language. I don't have a university degree, but I have a work visa. And I'm a certified TIG welder. Is there opportunities in the oil and gas industry? I'm sure the answer to that is yes.
Yeah,
I'm sure there's lots.
TIG welding is very common in cladding or the overlay work of oil and gas products.
Okay.
All right, one more question from online. Oh, here's actually one from California. Will robotics ever replace people in building pipelines? A little off subject what we're talking about.
I know pipelines are heavily automated already in the welding and joining process, so I wouldn't know why not. But you're still going to have people involved in making those systems work. Not completely eliminate people, but shift their job duties to more technical areas, I'd say.
Yeah. All right, that's it. We have a bunch of questions online that I'll get my team to answer later. Everybody, a big round of applause for our panelists. And Justin, I'm going to let you close this thing out.
Thank you again to our panelists. Thank you everyone who's watching online for joining us here on a beautiful day in Houston. Don't forget all the upcoming AADE meetings up in February. The API meeting February 14th, and again the big gala on February 17th. Amanda LaBrie, please stand up. Come see her for tickets. Come see her for sponsorships. We're having an amazing time. Thank you all for coming. We'll see you next month.